Hello, everyone, and welcome. My name is Liz Pemper, and I'll be your moderator for today's WJE webinar, Advancements in Facility Asset Management for a Data-Driven World. During the next hour, WJE architect Erik Murray and WJE engineers Holloway and Sarah Rush will discuss how new technologies and methodologies are being used to integrate facility condition data into large asset management projects to improve decision-making. This presentation is copyrighted by Jenny Elstner Associates. And now I will turn it over to Kurt to get us started. Kurt?
Thanks, Liz, and thank you to everyone for carving out some time to spend with us today talking about asset management. Just a reminder of our learning objectives, which were included in your webinar invitation. Nothing different there, just some takeaways we want you to come away from our time together with. Where we're headed today, we anticipate that most of you are somewhat familiar with the basics of asset management, which is why you're here. Others of you we recognize may be experts in asset management as a field. Our goal today is to touch on key concepts, advancements and trends in the field, and some of the benefits that a few of our clients have realized by incorporating an asset management approach. Of course, we're going to be focused on buildings and other structures for most of our discussion here, since that's our area of expertise. But want you to keep in mind that many of the concepts we'll unpack in our time together are adaptable to a range of situations. In general, any organization with a large number of physical assets and limited financial resources and time, that's us, can benefit from a system to objectively gather condition and operational data about those assets to make data-driven, informed decisions about repair, maintenance, replacement, or even reinvestment of resources towards or away from an asset or group of assets. The better the information that goes in and the clearer the understanding of your organization's context, the easier it is to make better decisions, especially when the right answer isn't obvious. To begin any asset management effort, a clear and direct strategy for prioritization is needed. It's the cornerstone of an asset management program. It's needed to consistently address the large volume of actionable information that's generated, the spectrum of conditions worth considering, and to make best use of limited resources and time. In the realm of building enclosures and structural assets, once any truly critical or hazardous conditions are addressed or stabilized at their earliest practical opportunity, and we recognize such conditions are pretty rare, owners have a ton of discretion about how to prioritize maintenance and repairs across the portfolio of your assets. One strategy that we've developed and employed with other institutional clients recently has been the use of a customized relative risk-based scoring index for the conditions found in a systematic condition assessment. The overall premise is pretty straightforward. The more risk a given condition embodies relative to the others assessed by the same methodology in the portfolio, and the lower the anticipated cost to address a given condition compared to other spending potential opportunities, the higher repair priority that item should be given. Applied consistently to any group of assets, such a strategy can enhance near and long-term risk mitigation per remediation dollar spent, can reduce overall long-term maintenance and repair costs by targeting construction projects for optimum timeframes relative to ongoing deterioration, and sometimes can even provide new insights for operational decisions. It helps you identify the low-hanging fruit that's not in plain sight and differentiate what matters most when the choices get tougher. With all of the data we have access to about our facilities, our business operations, financials, and other things, a prioritization strategy and even consistent and high-quality data aren't by themselves enough to wisely and proactively manage a large and diverse portfolio. Rather than a mountain of reports or raw data on individual structures or facilities, decision makers need that ability to interact with the data, to mine it, analyze it, and compare it in context of operational priorities and financial projections, both for capital planning as well as planning for repairs. An interactive asset management database is increasingly imperative to steward any large or complex organization's resources well in the long term. To construct one, data is often needed from both within and outside your organization. Too much or too little input or influence from within or outside your organization might result in misalignment of your asset management approach and system with your organization's needs and goals. As the owner or manager of a group of facility or infrastructure assets, regardless of your business or organizational model, you are the expert in understanding what matters most to your organization's success. A good asset management database or application needs to reflect the operational priorities, financials, and overall strategy of your organization as you define it. With regard to buildings, infrastructure, and other structural assets, they are very often a necessary means to an end for your organization. As such, viewing them as assets in that context requires collaboration with your consulting team developing your asset management program, such that your facility assets are appropriately understood, and this is consistently reflected in the prioritization systems that you implement. An independent, experienced consulting team can help you assemble the technical condition data about your assets that you don't have right at your fingertips. Reliable, timely technical condition assessment data about your assets is key to being able to anticipate what's coming down the pipeline. You can't navigate and course correct your organization's direction if the map that you're looking at is blurry or incomplete. The technical consulting team can work with you to develop a database application that meets your needs, perhaps integrating it with the tools you already use to manage other aspects of your organization. Whatever the right asset management database application is for you, it should have an array of tools that help you evaluate current assessment data and the ability to update and track conditions as new information comes online across your portfolio. Planning for maintenance and repairs to building enclosures and structures isn't new, but we've noticed an increasing need and demand for organizations to integrate assessment and planning for the skin and bones of their organization's physical assets with the many other types of assets that they manage. This is perhaps a natural result of a couple things. There's been a lot of advancement in data collection and management technologies that we'll touch on later, and there's been a bit of a collective shift in society's view of the permanence of buildings and physical infrastructure as it relates to operations of our organizations. We're looking at and using buildings and structures differently these days, particularly as it relates to our workplaces. They are finite, temporary assets just like anything else. Though other commonly managed facility and organizational assets are products or fabrications that may more easily lend themselves to a predictable life cycle of wear, tear, repair, and replace, building enclosure and structural systems too can be evaluated and characterized in such a way that their condition, repair, and replacement data can be incorporated into existing asset management programs. Since enclosures and structures have a relatively long lifespan, but also have a relatively high cost of repair and or replacement, which can be reduced and deferred respectively with appropriate maintenance, incorporating planning for those repairs and maintenance into your organization's bigger AM picture will help you anticipate challenges and avoid needing to react to unexpected large-scale enclosure or structural problems. How do we achieve this kind of integration? Well, you need to get the right team around you for your unique set of needs. As it relates to buildings, here's a list of some of the potential players on an asset management program team. Everything from the building owner and manager to folks who work with the buildings every day, various technical consultants, to, at the other end, real estate, financial advisors, and planning architects. It just depends on what your needs are and where you're headed with your decision making. Whatever your specific goals, a well-constructed, comprehensive asset management program should empower you to make objective, data-driven decisions about your assets to maximize value as you define it. Whether looking to prioritize capital planning for repairs over $5,000 or to sell underperforming or overly taxing facilities in your portfolio, or to create a 20-year campus improvement master plan, incorporating periodic and specific systematic condition assessment data of your building enclosures and structures into your asset management plan is fundamental to understanding where your organization's facilities are at so that you can chart the way forward. I'll turn it over to Sarah, who will lead us through some of the advancements in technology that we're seeing these days.
Thanks, Kurt. So while asset management is not a new conversation for WJE or the industry, there have been significant technological advancements in digital data collection and its analysis, as well as database software in recent years. Originally tracked using pencil and paper and later spreadsheets, today's data and data collection management tools are well into the digital and cloud-based age. In terms of what is predominant in the AE industry and most of the organizations represented here today, this process has all happened in a remarkably short time frame, sometimes in the span of a given career. It's a question for any of us to ask from time to time. Is my organization up to date with our tools and our approach to data collection and management? This progress is driven largely by the continuous improvements in the way we collect data for integration into asset management systems and software. And here's just a few examples. Mobile devices, tablets, and our applications increase the way we collect and share our data seamlessly in the field. Digital cameras, drones, 360 cameras, and video, robotic panoramic photography even, all help us collect more data at a faster and cheaper rate with ever-improving quality. GPS tracking and spatial markers in combination with these devices accelerate the speed and efficiencies in their use, and improvements in photogrammetry and LiDAR make modeling and post-processing capabilities virtually endless. Here's one quick example. So this model was used to document the atypical corridor geometry for this corridor, instead of sketching it out by hand as we would have, even 10 years ago. We identified delaminated areas of the floor tiles and got rough quantity taped off. We later utilized the model to identify the location of the core samples that we wanted to extract, and we tagged the location of photos that we took with handheld cameras within the model so that we could have quick spatial referencing once the samples were extracted. Photogrammetry models and imagery have been used in real estate markets for quite some time, with numerous apps and programs applicable to the asset management world. They just need to get integrated into everyday use. The data collection tools may be driving the progress in the asset management world, but tracking and management tools are improving too. We're in the Internet of Things age, where just about everything is somehow tracked or characterized online. Particular software packages all have their strengths and limitations, and new products and features are always around the corner. Similarly, for many of the mainline asset management software products, there's a whole category and cottage industry of third-party developers who can help you build custom add-ons, integrations, and visualizations. Software innovation is a hallmark of our world in all industries right now. What's important and new regarding asset management software and database applications is reflective of the trends in software and applications for other aspects of our lives. We can ask ourselves, are the software and methods we use to manage our workplace assets on par with software we use to manage our social media, fitness, or other things that are valuable to us? Where tools and software are always changing in this data-driven world, the need to develop an appropriate scope to obtain actionable information remains constant. So how do you select the right scope for your goals and objectives? Consider, what decisions are you trying to make? What data are you making your decisions on? And who is helping you tailor your data collection scope to meet your needs? Some strategies may look good on paper, but the greatest challenge lies in consistently gathering data and applying that prioritization strategy across a diverse range of conditions, so that the forest can be seen through the trees, like Kurt was talking about earlier. And because of the quantitative and qualitative and somewhat subjective nature of condition assessment, clarity of evaluation and prioritization approach and appropriate professional experience is needed to be able to turn these raw observations into appropriately consistent, actionable information within an asset management database. Sometimes in a property or facility condition assessment reports, we'll see some basic language such as, repair brick or repair corroded steel, or my favorite, repair and maintenance of the roofing will help prolong the life of the roof. Thanks for that. But for some due diligence assessments, that level of detail can be not only appropriate, but desired. For other instances, it may not meet an owner or property manager's needs. They may already know that their roofing assembly has localized deficiencies and that repairs are required. That's why they called a professional in the first place. Statements like these do not provide them with usable, actionable information, whereas the modified examples on the right provide much more detail, but require more effort and time on site and time in creating the deliverable itself, since they include conceptual repair recommendations, location information, quantities, and describe the causes of stress. Now I'll turn it over to Erik to start the case study portion of this presentation.
Thanks, Sarah. Well, we have 3 case studies to present to you today that exemplify and illustrate these concepts that we've been just talking about. All 3 of these case studies are different. They have different scales, the different project types, different reasons for being used, and in different regions of the country. But the tools and the principles of data collection and managing these assets is the same for all of them. So I'm going to start with a case study on roofing condition assessment and long-range planning. There's a school district in Texas that we've been working with for over 20 years, and 15 of those years we've been tracking their roofing assets, and over many properties. This particular school district's got about 92 facilities, total roof area of about 9.7 million square feet, and roofs that range in age from 1 to 32 years of all different types. And so what they really wanted to do is to be able to extend the roof life cycles and optimize the life cycle costs. It's a substantial amount of money in terms of replacement dollars that are embodied in 9.7 million square feet of roofing. And so it's, considering the annual cost of maintaining and then ultimately replacing those was considerable. So if the life can be optimized, life cycles extended, and probably more importantly, scheduling maintenance instead of reacting to emergencies, then that was a big benefit to the school district because things could be planned. And then re-roofing in particular could be scheduled based on condition and not just the age of the roof or when it's moved out of warranty. The challenges that we needed to overcome are very much the same as what Sarah was describing earlier, where we need to be able to get consistency in reports and ratings between different inspectors. 92 properties is a lot of properties to look at and keep track of during their life. Typical roof lifespan is 20 to 25 years for low slope roofing. And being able to look at those frequently enough required multiple inspectors. Being able to get reports and ratings and then output that would work with the district's funding and procurement standards was important. And then keeping the information current so it could be actionable, particularly during bond cycles, which for major repairs and replacements is how these sort of projects get funded. In particular with this school district, there were really three funding sources. There's operations and maintenance money, which was for relatively small things and some things that their own staff could do. There's repair projects that contractors would need to be hired to perform, and then major replacements, which would be capital improvements. We needed to divide up the projections into these kind of three categories. The life cycle cost is a big piece of this because just considering the current value in today's dollars of 9.7 million square feet of roofing, we estimate this school district has over $290 million worth of roofing. So if you figure that the average life of a roof, a low slope roof, is 20 years, and then you need to replace 1/20th of that roofing area every year, that would come to about $14.5 million a year in investment in new roofs. If the roofs only last 15 years because of neglect or poor maintenance or other reasons, that number would jump to over $19 million a year. But if instead you're able to extend the life of those roofs even 5 more years to last 25 years on average, that reduces that to about $11.5 million. So it's really substantial savings year over year that could possibly be gained just by optimizing maintenance. And the real key to that is being able to track and manage and be able to give attention to the ones that are most in need when they need it. So we started by surveying 15 to 20% of the facilities each year. That way each roof or each facility would get inspected a few times during its life. We'll compile the results and continuously track them, currently collecting the database, collecting the information into a database that's available online to the school district and to all the other project stakeholders. And then we can plan for major expenditures and track them over time. It's a cyclical process, and it's a continuous cycle, starting with understanding the condition of the assets, addressing the current problems, and then planning for the future. what our focus was things that were likely to cause problems with the building, meaning leaks primarily, but also durability, because that's what ultimately would lead to the roof wearing out early, is conditions that would allow water to get into and underneath, things like flashings and metal flashings in particular, corroding, and other sorts of things that might shorten their life. And then other things that would pose risk to maintenance personnel, because our opportunity when we were on the roof is to be able to see these things and identify them, and so we bring those up as well. The tools that we use to do this have changed over time. Our field data collection tools really started with paper and pencil, hand calculations on ratings, and then typing reports. Over time, we switched to using spreadsheets and tabulating and analyzing the data that we had collected, which increased, volumetrically over time. Paper and pencil field notes then gave way to using tablets to collect the data on the roof, and those tablets, we would have smart tags that we would place on roof plans that would include information like item types, severity, embedded photos, descriptions, recommendations. We started out using Bluebeam for this, and then moved to a program called PlanGrid because it offered some increased flexibility for us. We're now transitioning into using an in-house app that offers more customization and flexibility about the data we collect and being able to automate some of those processes. Digital photography has definitely improved over the years, and one of the things that's been really helpful is to have drones so that we can get to hard-to-reach places. It probably won't surprise many of you that there are some roofs that are just really difficult to access, and if you've ever climbed a 30-foot ladder to get up on a roof, that could be exciting. Data has been collected through a variety of different sources. We started out with Microsoft Access databases after we kind of moved away from spreadsheets and a variety of other SQL databases over the years. Currently, we're using a database on the QuickBase platform. And one of the things that's been helpful is collecting information that we've descriptions and recommendations and item types that we've collected over the years, so we can get better consistency, especially between the reports that are done by different inspectors, and also speed the time of production. And really, ultimately, what has really been nice about having the database is that it has made an interactive tool that really makes the paper or PDF reports that we produce somewhat obsolete. We still produce them, but it's easier to get the information that you need and really the level of detail you need just by going directly to the database. So it all starts with really understanding what you have through on-site surveys and condition assessments. This is an example of the kind of reports we've been producing for this with detailed recommendations and a rating scale that really comes down to the green, yellow, or red indicating which bucket of money that really belongs in maintenance, repair, or replacement. The rating system that we've used was something we developed based on what the Army Corps of Engineers developed many years ago. Army Corps of Engineers had a particular challenge, and even more significant challenge that we have in terms of trying to get consistency between different inspectors and their ratings. Thousands of properties that they needed to do inspections on, and widely separated and distant inspectors who weren't really talking to each other. How were they going to get consistent ratings and consistent surveys on their roofs? And so they developed this numerical system with some pretty detailed instructions about how to develop a membrane condition index, MCI, or a flashing condition index, FCI, but ultimately together forms a roof condition index, or RCI. We adapted this to these particular purposes, simplified in some ways to really speak to the specific needs of the school district, but then have tracked that, and so we can line these school campuses up side by side and see which ones are the most in need of capital improvements, in particular in terms of roof replacements. And so when it comes time for a bond program to be planned, we can use this to inform which roofs to include in that. One thing that's really been one of the best recent advancements is the accessibility of the data and the information. And this may be something that happens for you too. We had a lot of information that we collected over many years, and so did the school district, particularly when it was paper and pencil, printed plans, binders with reports. All this stuff kind of ended up in a closet someplace. And really the person that had been there the longest was the one that knew where to find these things. Trying to find even like a simple thing like the warranty for a roof when we needed to make a warranty claim, or the previous roof plan that was most recently produced so that we could use that for reference. Seemed like it took a long time to find. Now we have all this data collected together in one place where the information, all the roof sections, the roof surveys that have been done, and the reports and the data that went into it, roof design projects, not only with the plans and specs, but but all of the cost data that went along with it and who did the work, and the warranties that are associated with all of these roof sections are all collected together in one place and easy to access. So the database provides a really easy way to sort, filter, and just search through the data. One thing that's nice about it is it's non-linear, and so being able to navigate around really conforms to each person's personality and kind of the way their mind works. There's been some interesting discoveries too, things that we really couldn't do before, such as doing some keyword searches on the most common items that came up and most common issues that came up in our roof surveys led us to being able to identify the most common issues. And we actually adapted this information into a roof repair manual and with details and specifications to be able to put together an on-call roofing services reference manual that the owner can get typical roof repairs done without having to go through a complicated procurement process. Some things require a set of plans and a more formal procurement process, and that's kind of that 43% that's on the left side. But the other things are simpler to address, some of which they can do themselves and some of which they can just get an on-call contractor. And then ultimately, being able to produce reports that detail out what they need to consider for their next bond is something that's been very helpful for them. And this is something that's an ongoing conversation, and the current database has allowed us to be able to have unit prices for current market prices for roofing and have these reports be interactive, and not just something that we produce, but something that they can produce themselves by asking what things are important. So really it comes down to focusing on life cycle costing, getting data about the condition and then interpreting that data, and really looking at the long term and trying to really optimize the cost and the durability of these roofs. And I think that we've been able to save a considerable amount of money over the years because of being able to get the roofs to last longer and really help this district achieve their goals of optimizing their roof assets. Now I'm going to turn it over to Sarah to talk about our next case study.
Thanks, Eric. So this next case study was selected for comparison as it's definitely a difference in its scale and intent than Erik's project and exemplifies collaboration between multiple team members. For this project, we were part of a team that performed a feasibility study at over 60 vacant school buildings to determine a disposition strategy for each property, including the property's viability for adaptive reuse, or on the opposite side of the spectrum, identifying the building for potential demolition under a blight removal program. We knew our deliverables would be used to market the viable buildings for redevelopment, and in the near term, identify conditions requiring stabilization or hazardous materials, or buildings that could be mothballed and secured as funds permitted until redevelopment could occur. The diverse portfolio included a variety of different building construction types, materials, sizes, with most of the buildings being constructed in the 1920s and 10s, having historical significance with historical fabric. The project team consisted of multiple disciplines to meet that diverse project needs, including an architectural historian, an urban design and planner, a financial marketer, a local restorational contractor that helped us with cost estimates, and WJE, who assessed the building structural and building envelope components of each school. So all this is done with the primary objective being, what can we do with these vacant sites in a way that actually pencils out in terms of cost? To establish a categorized system and maintain assessment consistency across all of the portfolio of buildings, WJE developed a rating system based on the definitions and statistical methods used in the National Bridge Inspection Standards, which is a scoring system developed by the FHWA, or the Federal Highway Administration. This consistency gave the project team, city, community, and other stakeholders an objective basis to make decisions and allocate funding without some of the sensitivity that some of the communities feel on site with their ownership of the properties. Each pertinent condition observed was given a condition risk index, which took multiple metrics into account and assigned a numerical value for how much a given condition affected the building system as a whole. So individual condition scores were then summed to give a total building risk index, which was used to compare and contrast the various properties. These metrics are a numerical expression of our professional opinion of the relative significance of one condition or a set of conditions as they compare to everything else captured in the assessment, creating a common language for the asset management program as a whole. The scoring for each observed condition considered the building system it pertains to. For instance, a condition affecting the building's structural system and how it stands is assigned a higher rating than those affecting the facade or roofing systems. It also considered its impact on the performance of the corresponding building system, its size and distribution related to that system as a whole, and the consequences if it were to fail. So basically, to continue not being addressed in its current vacant condition. So for instance, distress within a vertical column is more important than distress within a certain floor joist. This metric also allowed our inspectors to exercise some judgment regarding general risks to the public. So if there was a condition located over a public sidewalk, for example, it was scored a little higher in comparison to an element that was over a roof level or within a mechanical space in the basement or in the back of house. The building risk index scores were helpful to the rest of the project team in understanding the current state of the building's bones and skin. It really served as one piece of the puzzle to be used in combination with the rest of the team's findings, of course. The graph at the top illustrates building score by system, where structural issues are at the bottom of the bar charts in blue, roofing issues are in pink, facade and exterior wall issues are in green, and relevant ancillary issues that our technical team found and wanted to note are categorized in yellow at the very top. You can see which buildings have more structural distress issues, which have larger segments in blue and may be more vital to that building's performance, versus the buildings where a new roof may actually address the bulk of the issues at a given property. So the ones with the larger pink bars in relation to some of the adjacent ones. Splitting the data another way, as shown in the bottom graph, we can evaluate how each building condition measures up once the sizes are taken into account. So some buildings, may not have scored very high just in terms of the building risk index on their own, but were found to be in poor shape when evaluated on a per square foot basis. So looking through the data with different lenses to really interpret what it's saying. Of course, the data was also evaluated in comparison with estimated construction costs, right? So here again, the construction cost for each building is separated by the building system affected, which more clearly shows where the funds are being spent on a given building, right? Some of those buildings have significant roofing expenditures. This information can be easily sorted by individual buildings in a given neighborhood, the size of the site, the age of construction, the number of building stories, the size of its parking lot, depending on what the developer is really looking for, and then can be cross-references with the findings of the market study. All of these metrics, graphs, reports, and colors could easily be managed by the team on their own or by us in whichever way that they felt most useful to them and answered the questions that they were trying to answer, which was a major benefit in using these tools and methods for this type of project. To collect all that data in the field, as Erik mentioned earlier, WJE used an iPad application that's developed in-house. Now that's not special, it's just something that we have determined as an initiative within the company. Each annotation contains the embedded data I mentioned earlier, including scoring for each condition, quantities, descriptions of distress, and some conceptual repair approaches or areas for further investigation. Each WJE inspector is able to see annotations from others in real time, increasing the efficiency of the site visit and communication. To process the field data, we utilized a web-based application similar to Erik's. It was also quick-based, which allowed for collaboration by multiple consultants and shareholders who each had a specific permissions within the system based on their role. But we're all able to review, analyze, contribute to the data, and collaborate. For instance, once the data was uploaded, the cost estimator was notified to jump in, enabling workflows and schedules to be fluid throughout the project. Other users maybe only had viewing permission and couldn't edit the data. So here's an overview of what you would see in the web platform. These are 3 individual buildings separated by rows, which contains the basic building information such as your building address, the name of the school, the size, the age of construction, and total restoration costs identified. Within each individual building is another table, which identifies various condition items listed for easy navigation and summarization. Overall building metrics were calculated based on individual condition scores on the left. The cost estimator was easily able to enter their information in this screen view or dive deeper into each condition to view all the photos pertaining to that condition and all the annotations associated with it. Within each condition item, you can see the raw data pulled from those individual annotations that were taken in the field. Similar types of distress or deteriorated conditions were automatically combined from the uploaded field data based on settings and preferences that we defined when developing the asset management program for this client. But as with all automated systems, it's never quite perfect, and human effort is still needed to verify and analyze the information collected. For instance, the individual quantities for each annotation would be summed, but then technical judgment was applied to kind of specify a final budgetary quantity and cost estimate. So some of the numbers were rounded up per se, where other annotations might have accidentally been categorized together and they need to be separated. So some massaging is really needed with any automated system. The key outcomes of utilizing these data collection and asset management tools included the fluid interaction they provided between the project team and the city in both the field and analysis phases of the project, as well as the consistent data collection and condition scoring metrics that could be filtered, manipulated, and deployed by various members of the project team, as well as the city and potential future development personnel. And data that was usable for all parties in both the near term and the long term, as the city has access to that full database, which can be shared again with developers in the future as needed. There was also efficiency in the allocation of personnel resources. And this is really a big benefit on the AE side, in my opinion, as these tools enabled the technical staff to spend less time creating the deliverables itself and the reports, and could really spend more time in the field and analyzing the data. Creating these tools takes an effort too, but that doesn't always have to be performed by the professional staff. So in terms of the project outcomes and based on the findings of our condition assessments, we did identify isolated conditions that posed a structural or life safety risk to the public in the building's current vacant conditions, which were immediately brought to the city's attention. We also pinpointed and prioritized assets to receive stabilization and mothballing funds as they became available. Most often these were drainage systems related to roofing, which caused damage to many of the interior elements below. We also identified sites with the best potential in combination with, of course, the other team member data and what they were finding to try to have swift redevelopment of these properties and meet the client's needs. So in a nutshell, that was kind of the objective of this project. I'll turn it over to Kurt to discuss it.
Thanks, Sarah. Our last case study is a structural and enclosure condition assessment in a greater level of detail, whereas the school study that Sarah was describing was more of a triage. This was meant to look at a diverse portfolio in detail to try to prioritize repairs across the spectrum of what was in play, and take a big problem and break it down into bite-sized chunks. So this last case study was for a large institutional client of ours that hired us to assess their diverse portfolio of properties, which was sprinkled across the Midwestern U.S. They included retail stores, warehouses, and multi-story community and dormitory style facilities. That portfolio of properties consisted of buildings of various sizes, ages, and construction types. In total, the systematic enclosure and structural assessment program included about 90 buildings, enclosing approximately 3 million square feet. But why? Why did our client ask us to take this deeper dive and perform a systematic condition assessment? I want to share this anecdote to touch on sort of the white-hot why, if you will, of why proactive enclosure and structural assessment matters. Put simply, unlike many other building systems which are managed as assets, enclosures and structures don't typically trigger an alarm or otherwise tell us if they're not performing well. If deterioration is concealed or it's not actively causing an operational concern, it cannot speak for itself. So if actionable quality technical information about these things doesn't make it to the decision makers in time, the only option left is to react when things reach a critical state. Assessments by experienced objective architects and engineers who understand existing structures can often identify progressive deterioration and sometimes design errors or construction defects before a failure occurs or the distress becomes critical and requires immediate repair. One poignant example from this particular institutional client that underscored the need and value of a systematic, proactive assessment was the corrosion and loss of the steel ties laterally tethering the brick veneer in this photo to the concrete masonry backup on this retail store, leading to outward leaning and rotation. In this particular case, we were called out literally 2 days before this collapsed in a thunderstorm, just in time to identify the hazard and have the owner put up some protective fencing to close a portion of the parking lot. The condition had been observed and reportedly been progressing for some number of years before we were able to come out and take a look at it, but the significance of it just wasn't understood. The clients expressed uncertainty based on this and some other similar types of close calls about deferred maintenance related to their portfolio was the why of this systematic condition assessment, the desire to move and goal to move to a more proactive and targeted posture towards building repair and maintenance. To get this done, it took a team of about 25 experienced structural engineers and architects with a broad range of experience with various construction materials and systems to get this done in time. We established a uniform data collection and categorization system to maintain assessment consistency across the portfolio, and observations were documented again in our proprietary tablet-based field data application. In order to assist the client in prioritizing repairs across the entire portfolio, we built a custom database site with information and photos completely characterizing each identified condition and provided direct access to that database site to our client. The updatable database allows the client to dynamically sort, filter, and search the live data as repairs were implemented, view summaries of portfolio-wide findings, and perform additional independent analyses of the data on their own. The client uses this information to this day in combination with other operational factors to facilitate decision-making regarding repairs and real estate transactions. As expected, in a collection of facilities of this magnitude, our inspection team found many significant items, approximately 1,250 distinct conditions in total, affecting the gamut of roofing systems, facades, fenestrations, and structural systems. A relatively small percentage of these were characterized as critical or imminently hazardous distress. In accordance with the definitions we established at the outset as a team of what these would mean to maintain consistency across the assessment. Though many of these items were unknown to the client and some were concealed, an experienced AE provides additional value in helping the client understand the relative significance of each, as opposed to just providing a more traditional assessment running list, laundry list, with minimal ability to help the client prioritize. By consistently applying based on our collective experience and project-specific training, the assessment-specific definitions of these terms, such as critical or imminently hazardous, We characterize the severity and nature of the distress we observe in a way that provides clarity to the client about where specific conditions fell on the spectrum of bad. How bad is bad really? In enclosure and structural asset management projects, AE experience is also helpful in helping the client differentiate between the not so obvious choices, when it's not so bad. There's value in having a professional be able to guide you into being able to differentiate between the medium things that are not so obvious. It's generally easier to suggest that a presenting condition needs to be fixed and fixed soon than it is to understand based on experience that it can be reasonably deferred if time and funds are limited and other items are more pressing. It causes us in the field to ask some deeper questions. Well, how is this sealant deterioration really going to affect the performance of this flashing? Or, oh, there's this splitting in this glulam beam. Is it structurally significant? But behind those sort of granular surface level questions, they're all aimed at answering the foundational question. How important is this condition I'm looking at right now relative to the other conditions we've observed, really? Some key outcomes from the systematic condition assessment project obviously found some critical or hazardous conditions in portfolio properties this time. Pictured here are some fractured wood bowstring trusses that required immediate shoring, a temporary stabilization, a change in loading, or even just whatever time was possible with these things, and they were unknown prior to the assessment. But for the majority of items, we're just helping identify things for long-term repair prioritization. And then, not explicitly a goal of the study, but one of the key outcomes that emerged from the quality of data was sort of the ability to identify the stinkers, the buildings where operational value versus what was going to go into the skin and bones of the building long term was no longer of value to the client, and they were able to make decisions about, well, maybe it's time to let go of this one and sell it. And so we know of numerous facilities for which our data was helpful in identifying those stinkers, so to speak. The real power of a systematic condition assessment and an interactive asset management database lies in the ability to break down the big challenge into small bite-sized chunks, objectively and consistently, without undue influence from human perception. Hey, we're all wrong sometimes in how we perceive things. Or being beholden to the squeaky wheel gets the grease kind of mindset. We can step back and we can see the big picture to make objective decisions based on the facts embodied in the data. The totaled scores of condition risk indices and things like that for each asset or group of conditions paired with cost information or other pertinent data allow for an unbiased prioritization and offers other powerful insights into the data, mining and charting it to identify overall trends and planning opportunities. For example, the top chart here shows that in this particular portfolio, a relatively small number of buildings embodies a good chunk of the risk that we identified. Down below, we can see how a relatively small number of conditions were flagged as eminently hazardous or critical, and then more of these things are sort of on the medium to minor scale of how significant they are. We can further break that data down and look at these by system, whether it's structural, roofing, or facade conditions on the chart at the right. Coupling asset management approach and interactive database tools with the capability to efficiently amass data for multi-asset portfolios unlocks powerful perspectives from our experience to help the owners in prioritizing allocation of repair resources where they will do the most good. Looking at, say, the same portfolio regionally, we can see that in some cases, we're looking at relatively low bang for your buck in terms of the amount of risk we'd mitigate investing, say, in one region versus another by looking at risk index score as compared to anticipated repair costs. And so that can help target resources specifically. We can further break that data down building by building and see that, again, like that stinker index suggested, some buildings, like the really tall red one on the left with the low blue outlier, that may be one that is one that you want to unload and sell, whereas some others where you have a high cost value for what repairs you're going to put in and relatively low risk index, those are no-brainers that, yes, we want to try to stay on top of repairs and maintenance. Also, by periodically updating the database as repairs are completed or new and updated assessment information is available, owners can track progress and more easily shift priorities as new information becomes available. On the left, we see a bar chart sort of tracking progress again through those regions of how much of the initial findings of the study have been addressed, and sort of an overall ticker rain gauge, if you will, of progress to date on making repairs on the portfolio or addressing it by other means, sale of a building or something like that. With that, I'll let Erik bring us home.
Thanks, Kurt. So to sum it all up, asset management is not a new concept, but the tools to do it are changing and improving. And it's actually a pretty exciting time to be in the business because some of these tools are pretty cool. And an important aspect is thoughtful design of your asset management program. And that's important so that you can gather meaningful data, answer the right questions, and provide good information for decisions, not just data points. Technical AE involvement is helpful to provide judgment for interpreting that data. And without that, you may just have data points rather than actionable information. Good information facilitates both short-term and long-term planning and budgeting, and ultimately leads to the end goal of optimizing maintenance and capital improvements and saving money. So with that, I'll turn it back over to Liz to open it up for questions.
All right, thank you, Erik. And thanks, Sarah and Kurt. That was a great presentation. Okay, let's take our first question. What was the name of the database that you are currently using, having replaced Access?
Oh, Liz, I can take that one. So actually, there's quite a few questions in the chat about specific software. And I did touch on, maybe 20 or so, 10 or so up front, but like there are hundreds of software out there that just add to an ever-increasing list. So I think one of the direct answer to this question is I'm not personally familiar with Access. There's about 10 other ones listed in the chat, some of which I am familiar with, some of which I'm not. But I think the most important thing to know is that there are these options and to pick the ones that work best for your scope and your budget, because these things do have a cost. So that's kind of a nutshell answer to that question. Thanks, Liz.
Yeah, and Sarah, you guys have used QuickBase quite a lot, right?
That's the one we picked, and that was evaluated. Actually, Kurt can speak to that more against another one. But then again, cost came into an issue, and how we use it for our clients might not be the same as a different manager who's working more with also tracking furniture or MEP. We're only working with the building and structure often, unless we're integrating our data into an existing client's system.
Yeah, no, Sarah, that's a great point. QuickBase is one that we've enjoyed working with and had good success with, partly because it's so intuitive. As non-programmer folks, we're usually versed enough in programming as engineers and architects, professionals, to do a lot on our own and figure things out, but it's a low-code platform that enables us to get a lot done internally quickly when we're building an application for a client.
Okay, great.
I'll just say too, I was just going to add that we have tried quite a number of other things, including kind of custom, SQL databases that we've developed in-house. But one of the things helpful about having an established platform is that you don't have to, solve all the bugs or make all the mistakes yourself.
This is a good follow-on question. What are some of the customization features you identified as necessary and not commercially available in another field data collection tool that led to the decision to build your own custom application?
So that's probably referring to the field data collection component where we created our own in-house app. I think there's several different software tools out there, but we wanted to have one that really linked to photographs, especially with spatial data of like where we are, and tied it into like a field sheet and a PDF. And then in different annotations, we can also create forms on our own and share them with each other. For instance, like a concrete condition assessment, there's toolbars for spalls or water filtration through joints that have even more information embedded. So we can specify quantities, or we can specify how bad is it. So it really just gave us the customization to get everything that we were already doing in the field on paper and pencil, just in a faster and more concise and clean way. Like, it's definitely not a perfect system, but that was we wanted it to be more efficient in the field.
All right, our next question. How did the architectural historian's participation influence decision-making for the school's assessment? Was there a numerical consideration for significance?
Yeah, so each of the teams had their own rating scale, and then we made this, really beautiful clover leaf that I should include. But yeah, each team had their rating system, and then each team's score went into an overall property index for the whole group as a whole. That answers the question. But yes, all of them came into play and was a metric that was considered for sure. And again, all of our data is, actually I should touch on this anyway. There's a website link in one of the resource links for this presentation. It's all available publicly online because it was a city entity that funded this project. So a lot of our data and a lot of their data is filterable and searchable. You can find a little bit on which ones had the best historic scores, for instance.
Yeah, and Sarah, that link's not yet up in the resource list, but I will add that this afternoon, so you can re-access the webinar console that you're in right now and access that link later this afternoon. Okay, our next question. This has more to do with the life cycle maintenance of the data on these cloud-based assessments. The question is, it would be great if we could create large online data resources for doing assessment of capital needs, but where does the data live, i.e. where is it hosted, and what are the costs associated with keeping that information accessible for an extended period?
I can take that one. I think there's options available out there, and a lot of these cloud-based storage things, whether it be Amazon's version or Google's version, whatnot, can be integrated into the asset management programs themselves, meaning that the data is often not natively stored, say, within QuickBase or whatnot. There's limited storage within a lot of those programs themselves, but they can talk to each other, right? And so you can have the same secure storage that you have for any other documents that are hosted on a Google server or Amazon or whatever. And for some clients, that may present a challenge, say if it's like a federal client or somebody who needs to have their data locked down on a physical server that resides in a physical place. But in general, for most of our clients, there are a myriad way of storing the data, making it accessible over the internet for an indefinite period of time at a very low cost, even if it's a lot of data.
I think the only thing that I'd add is just that it does have a cost to host it, but it does have a value to host it over time too. If you maintain and update your data, like Kurt's last case study, for instance, or Erik's case study, where they track it over time.
Okay, we're going to run a couple minutes over just to fit in a few more questions. We'll try to get in 2 more here. So second to the last question. Your examples seem to be looking at current condition and prioritization based on worst first categorization. Do you use the information to identify low-cost maintenance to prevent more serious issues? Do you do anything to project the rate of deterioration of assets?
I can try to speak to that a little bit first, if you're all right, Erik and Sarah. So yes, to all of it. So a lot of times these condition risk indices that we come up, we are embodying a lot of judgment from our professional experience in that. So it's not a worst first only kind of scenario. The risk that a condition embodies or sort of the severity or advancement of deterioration that we're finding is only one part of the overall score. The cost that's involved matters, right? The sort of length of the fuse on it matters, as you pointed out, and those things can all be assessed based on our experience when we're evaluating these parameters consistently in the field. And a lot of times our in-house iPad application for field data collection, we're using common forms such that our inspectors are consistently making sure all those parameters are evaluated for each thing we find in a consistent way. And when you take that and put it into the database, that lends itself to that risk index score that is consistent and usable across the spectrum.
I can also add that, in the roofing example that I talked about, we do 3 to 4 roofing inspections during the life of the roofs typically. And so we are able to track the deterioration of some of those some of those items, as we're looking at them a few years later, and also, for that matter, items that were deferred and didn't get addressed, be able to identify how much more serious they are.
All right, our last question. When doing a volume assessment, the more sites you see, the wider the range of issues you see that you may not have been looking for on an early evaluation. How do you handle this?
I'd love to jump in on that. That's a great question. And it's true that within a portfolio, when you start out looking at the first couple of buildings, you're only seeing the range of conditions present in those buildings. And that is part of the value of having an experienced consulting team assessing these buildings, is that you're not drawing upon just the experience of that one facility or those first few as you embark upon the assessment and then trying to maintain consistency retroactively. What you are drawing upon is the collective experience of whatever your consulting team has seen in their entire career of experience, right? And that's some of the value that folks like us can bring to the table. Is bad as far as we've seen it, almost everything we see is not the worst we've ever seen, right? And so we can put it in the spectrum of what's ever been seen out there when we're rating these things in the field. I hope that helps.
Kurt, I would just add for the Detroit Public Schools, we also knew that we would run into that a little bit because these are such interesting, weird structures in some cases, and in weird conditions. Having material scrapped out of the building was new, relatively new. It's not usually distressed condition that we typically see with an occupied building, right? But we built that, we knew that uncertainty, again, based on experience to some extent, and built that into our tools and into the metrics. And some of those ancillary, there was like a yellow section on some of my bar charts that was yellow, and it was like ancillary conditions or ancillary structures. And that's exactly what we had to do, is in the middle of the data pivot, because of some of the chimney stacks, for instance, weren't technically part of the scope, but they were in pretty rough shape. So that's how we pivoted on that one.
All right, thank you, Sarah. Thank you, Kurt and Erik. Really appreciate all the time you took to answer questions today, and thank you all for hanging on the line with us for a few more minutes. We hope it was educational. If you have any questions about today's presentation, please don't hesitate to reach out to Erik, Kurt, or Sarah. They'd be happy to answer questions. And if you have any questions about WJE webinars, please reach out to me, Liz Pemper at WJE.com. So again, thank you so much for your time, and we hope you have a great rest of the day.